along with you young aspiring pyromaniacs, raise your hand if that's you. Yeah, that's what I thought. Thank you, Logan. We're taking that after class. You think there's one kind of fire called fire. Okay? There's a reason why for years you have to go to the fire academy and why people can get an entire major in fire. If it was just fire, you wouldn't need to go to college for 4 years to study it, right? There's actually over 20 different verified forms of fire. Wood fire is different than a metal fire, which is different than a liquid fire, which is different than a dense fire, which is different than an air fire, which is different. I mean, there's just all these varieties of fire. So what you're seeing today, I know what kind of fire that is. I actually know the lacquer that they used on these desks, and I made sure that the lacquer they put on the floor was a specific type that's flame retardant at certain temperatures. Whereas you would just spray this around in your room, light it on fire, and see what happens. Okay? So, again, I have kind of back researched this. I don't know everything about fire, but before I've done every experiment that I've kind of done, I double check it, I look it up online, I check it in a textbook, and I go, all right, it's legit, I can explain it, I know what's going on. So, if I tell you to move, listen. All right? My darling, the lights please.
Oh, sorry.
Get the other light there, Adam. Yeah, fire's easy to see.
Whoa.
Okay? Now, we can actually talk about pressure. This is stuff I don't talk about with my freshmen. But the flames will always point to the inside. The reason the pressure of the air out here is greater because it's colder. Hot air has less pressure, so it's actually pushing it to the inside. Again, you try that in your room,
It's going to be awesome.
you're going to get in trouble. Now, here's something you have wanted to see for the last 13 years. Your teacher's desk completely in flames. Mike, do you a favor and sit the heck out of your chair. We get it to travel down. There you go. Come down.
Oh my God.
Okay. What's really cool is if you watch, the head, kind of, they call it the head, kind of like the snake, will lead, and then right behind it, it goes out real quick. It pushes all the air out, and then when the air comes back in, it can reignite the fire. All right? And again, if you know enough about what you're doing, you can do that and not be too worried. But again, you would try that at home.
Freaking out.
And maybe not know quite what's going on.
Which flammable substance are you using?
Fire.
Yeah, what is that liquid called? Where do you buy it?
Yeah.
Is that one of those
Guy who hasn't taken my class before, you're not getting the answer.
That is so cool.
But again, if you watch, the head leads and then it goes out right behind it.
I think I'm going to become a physics teacher now.
Don't worry, Kennedy, he's a freshman. He'll have your question in there.
Okay? You see how it kind of goes in those waves? When it gets hot, it pushes all the air out. Hot things kind of expand, right? So it pushes it out, and then right behind it, it's quite not. Now this one's always fun where you just go. Barbecue's ready. Notice the twisting motion.
That was
Is that
cool.
from the heat?
Yeah, so it pushes itself in naturally. Let's see what we got. Tornadoes don't twist because they're tornadoes. Tornadoes twist because in nature, the easiest way to transfer things is through a swirling motion. It's the most efficient way, which is why when cold air in the clouds and hot air from the ground transfer, they twist. Not because they want to twist, because it's the most efficient way. Just like when bath goes down a drain. You don't have a special drain at your house, it's just the most efficient way, and that's the way nature does things. Alright, we got one more big explosion and then we're done. I know. Lopez, lights.
That was kind of easy. Come on, Kennedy. I did that with my floor and it blew up. It was pretty trippy.
So,
Oh my god. You made like 3 S's.
now, something we can talk about with fire. One thing I want to point out that's interesting, if I make a big flame right here, notice it all pushes to the middle. Alright, it's the same reason that you get that kind of mushroom cloud. The air out here is cold and lots of pressure. That's hot with little pressure, and this air is squeezing it all in. So when I do that, you'll notice it all points to the middle. It's this cold air pushing in on it. Okay? If you're wondering why your desks are all on fire.
Two more.
Because I light all of your desks on fire.
Put out the fire with your fist. Oh my god.
Here, clear off this thing. Oh, this one's dirty.
I want this on fire right in front of me.
Clear this one here. We'll get a good fire going. Let's go.
I'm gonna punch you in the face. Don't touch me. Two more. Put some charcoal and start barbecuing. We're blowing stuff up in here, thank you. Shut the door.
Just hold on for a second. I'm busy. Andy, do me a favor. Get out of your chair now.
Hey, Tyler.
Hey, look, I'm Andy.
Hey, what's up, Andy? Andy.
There's something you have wanted to see every day of high school.
Burn the desk.
I know you've all sat there. There was your day. Now, something I want to show you. Does anybody notice that it's kind of twisting? Freshman, remember when we studied tornadoes? Okay, twisting. Does that happen? Do I have to make that happen? That happens naturally, right? When water goes down a drain and when a twister happens. So if I get this thing really hot like this.
You better
Notice it starts to spin a little bit. Again, it's like a twister. That is nothing we're doing on purpose. That's something nature does. The easiest way to transfer stuff is through a twisting motion. There you go, freaking guys out. Oh, yeah.
Star.
You
gotta make the circle.
Alright, if a demon flies out of the floor, I'm gonna say.
No, you have to make the circle before that.
Let's see how high we get this thing.
I would.
Yeah, I burned off half my leg. Yeah, that was not good.
Then just start rolling on the floor.
Alright, get one more.
Hey, Gabe, catch the fire. Okay. Whoa.
There you go. So, if this is cool to you, if this is awesome, be a firefighter. This is the type of stuff you get to practice. And they'll say, here's a piece of wood, burn it, and then study it. Here's a car, burn it, study it. Okay? Don't do that at your house, okay? Don't be an idiot. There's a reason it takes 4 years to get a degree as a fire inspector. If fire was this thing that we already understood, you wouldn't have to go to college for 4 years. Alright? Don't be dumb enough to think that you in your backyard know what you're doing. You don't. Okay? Say bye.
Oh, man.
what we're gonna do is we're gonna fill that balloon with as much hydrogen, H2, as humanly possible. Then when we light it on fire, that balloon wasn't good enough. Okay, tie that on there. The oxygen and the hydrogen are gonna mix, and what you're gonna see, when this thing explodes, that's good. When this thing explodes, you're gonna hear a splash afterwards. What does hydrogen and oxygen make? Water. Water. Now, to give you some idea, it's hydrogen. Just to give you some idea, here's how I'm gonna light it. You're good, man.
Yeah.
Happy Fire Friday.
That's coming towards me. Following students in the main office, please. Shelby Ebert.
Sit up, Roland. Get a course.
Colin Walton.
I
know.
Okay. In the main office, please.
There you go.
This is killing me.
Mama, pizza.
What is it with this experiment? To you, holy
Oh,
moly.
man.
Come on.
Dude, really, balloon? That's up, huh?
You're so weak.
Oh, God.
Oh my God. Oh God.
Yes. That'll work. Spin it down.
Is the ice gonna cool it?
No, not that much.
You